There's a
Okay.
cat on the back of my chair in case something suddenly pops into existence.
Cats and owls. So we're live on YouTube. And we'll let
Yep, there he is. Excuse you.
strictly indoor cat.
Yes.
Okay, I'm gonna pull us up live on the webinar. Okie doke. So people will be able to start popping in now. Yeah, here they're starting to come.
It'll be another minute before.
Yeah, I think we have 360 some folks that signed up from 14 different countries and probably around 40 US states. So,
Yeah, you said 17 countries the other day. So
oh,
did
maybe.
you?
Anyway, a bunch
I'm back.
of different countries. So heavy on the US, of course, since that's where this issue is, you know, the spotted owl part is most directly relevant. Rocky, do you want to start us off with some potential spotted owl calls?
Yeah, sure. I'll try. As I said, Carla, my voice is a little bit scratchy this morning for some reason, but David Weens last time went through some northern spotted owl calls, and I'll do that for the purpose of contrasting a little bit the California spotted owl and Mexican spotted owl, because there are three subspecies of spotted owls. And the northern spotted owl typical call is 4 notes given in a series of 2 sets as follows. And the male and the female can be distinguished by the pitch of the call. So that would be more typical of a male call, and the female is higher pitched. It sounds something like this.
The Zoom is cutting out your higher pitched female.
Yeah, see that higher pitch, it cuts out. Well, sorry about that. The California spotted owl sounds almost exactly the same, but sometimes on the end of the second series, they will truncate it, and sometimes only give one 4-note first series. So it might go something like this. And it drops off the last one. A Mexican spotted owl sometimes will truncate it as far as only going. So they might just might do it very quickly. And this is a sort of a low hanging fruit if there are any students out there. Nobody's really compared the vocalizations of these 3 subspecies, which would be sort of interesting because it's been stated in papers that they are phylogenetic species, That is, there are genetic differences amongst them such that you might consider them a good species. People have pondered that for a while, and the plumage itself is a cline. So the northern spotted owl is darker, has bigger spots, bigger white spots, and whiter, and then it grades into smaller spots and lighter brown color as you go further south. But that's a cline, and that's not indication of any sort of strict genetic barriers. But vocalizations are a little bit different because they use that in communication and so forth, and sexual signaling and whatnot. So that's a study that somebody could do at some point in time, is compare these three subspecies as to how they are different. And another call that all the subspecies use is called a series call, or which depicts agitation, and it goes something like this. And that's almost not dissimilar to the barred owl, which we'll speak to a little bit today and possibly spend a fair amount of the discussion on it. The barred owl sounds like this, their typical call. So it's who cooks for you, who cooks for you all. And the interesting thing that I found with owl calls, and I learned very quickly in one of my early studies in 1980, I went out with another biologist, and we were trying to call spotted owls. And I had heard spotted owls, of course, and he started calling, and it was like, and I almost started laughing. I said, "This is really what is he trying to do?" Well, sure enough, an owl answered, and I thought, well, that's pretty weird. And sometime later, I was working in the field, and I heard a logging truck backing up with his beeper, and the beep was going beep, 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 and the spotted owl started answering. And so I realized that it's not so much, and this is for people who are trying to get calls to owls to respond to you. It's not necessarily how closely you imitate them. It's whether you get the cadence right and the sequence right of the calls. So that's sort of a little interesting tidbit there.
Nice.
So people are probably almost all arrived now.
Yep.
Got a lot to cover.
Yep. Let me give you a quick intro and we'll get going. Thanks for doing the owl stuff, even though Zoom censored your owl calls slightly as we went through.
Yeah.
But we could see you moving because you were into it, so we could tell the cadence for sure. So just for anybody who's new here, the International Owl Center is located in southeast Minnesota in a little tiny town of less than 1,000 people, just because it started here and evolved out of other owl activities. This series started during COVID, when kind of the whole planet was shut down and we were looking for other ways to do education, and we knew all these great owl people from all over the world, and the whole world was forced to learn how to do Zoom. So we thought, well, hey, would you guys do some presentations? And it really took off, and it's been a great way to be able to share really important owl information with people all over the world. We've tried to keep it free. And that's thanks to those of you who are watching, who are able to donate and make contributions. There's enough of you so that we're able to do this and keep it accessible to all, which is really important, especially for folks who are in countries where currency is not worth anything compared to US currency. So it's open access for everybody. This presentation will be saved on Zoom. So if you miss it or your friends missed it and want to catch it later, you can watch it on the International Owl Center's YouTube channel. If you're watching us in Zoom, the chat is disabled. If you're in YouTube, the chat is open because we can't disable it. So if you're in the YouTube chat, make sure any comments you're typing are on topic and relevant and of relevance. And sometimes the chat gets saved along with the video, so beware of that also. We do have chat room moderators in there that'll be watching the chat. When we get to the Q&A at the end, if you're watching in Zoom, usually it's down on the bottom in your menu bar, you'll see a Q&A. That's where you can type your questions. In YouTube, you can type it in the chat. And Tristan Williams, I think he sometimes shows up as Owlykeep. He will forward the questions over to me, and Joe and I will take turns asking the questions of Rocky, and we'll get through as much as we can. We'll cut this to 2 hours total. So at 3 p.m. Central Time, we'll cut off questions if we haven't gotten through all questions by then. I need to thank Rocky for doing this. I think I've been asking you for what, 3 years now to do a presentation. And conveniently, it didn't work out until just now, which happens to be the most relevant time possible to be doing his presentation about spotted owls and conservation conflict with the comment period open on the proposed barred owl management for spotted owls. I'm trying to do a little background on Rocky. He sent me his CV, which is like 57 pages long. So this is just little tiny highlights. So he earned his PhD in zoology from UC Berkeley under Aldo Leopold's son, A. Starker Leopold. He was a professor at Humboldt State University from 1987 to 2000. He was a professor and held the Gordon Gullion Endowed Chair at the University of Minnesota from 2001 to 2016. He's a fellow of the AOS and the Wildlife Society. He's been done editing work for multiple prestigious scientific journals. He's published over 200 peer-reviewed papers, has given over 100 scientific presentations. He's gotten over $14 million in research grants. And one of his publications I do want to pull out, he was one of the editors of Conflicts in Conservation, Navigating Towards Solutions. So this is something that he's really spent a lot of time on and has been doing spotted owl research since 1980. And although he's retired, he is still doing spotted owl stuff. His list of awards is very long. I asked him which one was kind of most meaningful to him, and he said the Caesar Claiborg Award from the Wildlife Society for outstanding contributions to applied research and management. So with that, I will turn it over to Rocky. Thank you for joining us.
Thank you, Carla. Let me do a little screen share here. There we go. There we go. So you may not have noticed that I changed the title of my talk slightly here. I put the word reflection rather than symptom because it sort of sounded like a disease, and after COVID, I didn't want to be reminded of diseases anymore. And so about 2022, David Wiens gave a wonderful presentation on the northern spotted owl, and I reviewed that last week and thought it was very comprehensive and brilliant in its execution of the science behind much of the spotted owl research in northern spotted owls. So what I'm going to try to do here is talk about a different kind of issue, and that is about conservation conflicts, which David didn't really speak to at length, and also to fill in some gaps that he left out simply because neither he nor I will be able to be close to talking or saying everything about spotted owls. And so I'm going to do a couple of things. One, talk about conservation conflicts and the roots of those, so that those of you who are involved in conservation conflict, have interest in it, or anywhere in the world, many of these concepts will be applicable to you. David said that the spotted owl is one of the most studied species of bird in the world, and certainly probably the most studied raptor in the world. And as a result, the spotted owl has become what we call a model species. This is when there is so much known about the species and there's so much data that it becomes a platform to develop other things that have general applicability to science. And just pulling out a few of these examples, occupancy analysis was developed by Jim Nichols primarily as a way to census or to survey for spotted owls. And because of the problems with estimating juvenile survivorship, a novel way of using the Jolly Seabird estimator was developed by Roger Bredel from France under the guidance of Jim Nichols. And then Program Mark, which is a population program, an analysis program, was developed by Gary White to facilitate spotted owl analysis because the data sets were so large and complex. And now everybody in the world uses Program Mark to do population analysis. And there's then advances in conservation applications like novel conservation designs based on, that should be solid, not sold science. That's a problem with spell checkers. All right. So here's a couple of, throughout this talk, I've given you some references that you can research later at your convenience. But returning to the question I posed in the title, the answer is yes. It is both a problem and a reflection of society. And this is the reason why. And this, again, as I said earlier, this applies to conservation conflicts in general and to spotted owls in this case. People often have different goals and visions, but when those differences are so entrenched that they block your ability to think critically or to engage in rational discourse, they prevent problem solving. And this sort of a situation may reflect larger societal problems, which is what I think is happening with spotted owls. That's what I'm going to try to do here, is show that conservation is both a wicked problem, as I've published elsewhere, and a reflection of societal changes. And I am not an expert in conservation conflicts. What I've learned about conservation conflicts is what we call trial and error learning, just being involved in it with a spotted owl, and working with my colleague from Scotland, Steve Redpath, who was a leader in conservation conflicts. And Steve invited me to work with him on some European Union issues revolving conservation conflicts. And we published a major paper out of this and the book that Carla referred to. So if you're interested, you can read further on those. And well, one thing that underpins virtually all conflicts is trust. When trust fails between individuals or between parties, agreements cannot be made, or they're very fragile. So in the spotted owl conflict, there are a number of things that had to have happened, as there are with all other conflicts. You have to have willing adversaries, people that are willing to engage in conflict. The issues have to be broad enough to attract people outside of the immediate impact of the situation. And there were faulty assumptions for early management decisions that agencies made that led to greater and greater conflict. I'm not going to talk about those in this presentation, but that they may be relevant in questions later, because people say, well, why don't you do this? Well, if that's a fault, if that suggestion is based on faulty assumption and you do that, you just cause more conflict. And there was substantial scientific uncertainty at the beginning of the spotted owl conflict. There was also both fake and agenda-driven science that actually undermined normal scientific information and process. And there was a lack of acceptance of solutions, whether they be top-down or bottom-up. And I'm going to explain those to you in a second, what top-down and bottom-up solutions are. And then there was this lack of trust. And it was not limited to people not trusting agencies. It expanded to not trusting industry and others not trusting environmentalists. So who are the adversaries here? All conflicts require adversaries. Well, in the case of the spotted owl, there were ancient forest advocates, and there were the people of the United States having wanted to have an Endangered Species Act to protect species from going extinct. And on the left, you see these giant trees where spotted owls in the forest where spotted owls live. Here's my wife trying to get a ticket from the park ranger, climbing on a redwood tree, and a couple of my college roommate here from New Mexico and his wife. And on the other side, some of the adversaries were the timber industry and timber dependent communities and the people whose livelihoods depended on logging. And there's a lot of money involved in this situation. This is me back in 1980, before I met Carla and I had dark hair, and not white like it is now. This stack of old growth redwood logs is probably worth about $2 million. So there's a huge amount of money involved in this situation. So there's money, information, and beliefs are themes that underlie many conservation conflicts. None of these are inherently bad, but they are because they are the foundations for modern societies. But when they supplant the ability to reason and interact congenially, they prevent conflict resolution or conflict management. As a consequence, each of these factors influence conflict parties in different ways. And so what I'd like to do is kind of view this spotted owl conflict as a circle with the events depicted on the outside of the circle with the time and when they occurred, and in the center, the actors that were involved in these events. So the start of this conflict circle is logging or money. So logging was, at the time of the spotted owl became an issue of importance, was a global conflict. People all over the world were worried about the loss of ancient forests, and people were in conflict over that. Now, I will interject one thing quickly here that is a misnomer that we've tried to change in the literature and have so far been unsuccessful. People always use the terms owl-logger conflict, or the owls in conflict with loggers. The owls are not in conflict with anybody. It's people who are in conflict with each other. So the animals are just the symbol or the species over which people themselves are in conflict. So we should do our best to try to avoid the euphemism of owls versus this, or lions versus grazers, or whatever. It's people that are in conflict. And logging, clear-cut logging, was viewed as negative by many people, particularly in the United States. And so you see here this forest quite close to my house here. These are pristine forests, support many unique species, provide high quality water, and are important for carbon storage and the like. But when they're clear cut, many of these values are destroyed. And besides being ugly, they cause erosion, damage to fish stocks, and so forth. So people were concerned about this. And in the Western United States, 30 or 40 years ago, the Western ancient forests were under threat. And owls at that time were thought to be old growth obligats. So we had this dichotomy, conservation and logging, with adherents, actors that were interested in one or the other of these two issues, conservation or logging. And so almost immediately in many conflicts, bottom-up solutions are tried. And these are solutions in which people in conflict try between themselves to negotiate a solution. So, for example, if you have a house with a yard and your neighbor has a house with a yard, and he puts up a fence and the fence is not to your liking, well, the bottom-up solution is to simply talk to them and say, hey, can you just take a chainsaw and cut half the fence down or something like that. A top-down solution would be the opposite, where you sue them and try to get the courts to have them remove the fence. And we tend to think that of these as ideal, because if people actually agree on something that's they're involved in, they're likely to uphold the agreement. However, because spotted owl conservation had much broader socio-economic implications and conservation implications, these bottom-up solutions didn't work at the beginning. And this is because there were outside actors who became a driving force in snatching the conflict away from the local parties and making it a much broader issue. And we have a term for that. We call it elite capture. Of course, elite capture is defined in various ways in conservation, but I'm using it in the sense that outside actors with power, money, or whatever can override the interests of local people. So in the case of the spotted owl, on one side, you had ancient forest advocates from throughout the United States that co-opted spotted owl, the actual owl conservation process, to broaden it to ancient forests. And then you had the forest industry that co-opted loggers and local communities as a surrogate for their broader interest to prevent to stop the prevention of clear-cut logging, for one example. So elite capture, often aided by money, power, and politics, can lead to something we call power imbalances. And power imbalances often lead to what we call top-down solutions in conflicts. So top-down solutions are laws or litigation, and they can counterbalance elite capture in the following ways. And so science can be used to inform agencies or legal people about what the true situation is about the status of owls, say the northern spotted owls and the Mexican spotted owls. And in this case, the scientific evidence was overwhelming that both the northern spotted owl and the Mexican spotted owl were under threat. And so they were listed as threatened species under the Endangered Species Act. And the California spotted owl was recommended for listing in 2023, but long after the northern and the Mexican spotted owl were listed as threatened species, even though the same kind of information was available for the California spotted owl. And I'll talk about the California spotted owl to fill in behind David, because he didn't speak to them very much. He just mentioned them in passing. So here we already had our major issues here, conservation and logging. And now we have these top-down solutions being invoked because bottom-up solutions didn't work. And so this is Spanish got thrown in there. That means the same actors are involved here. And now we have something different. And this is a nod to my Argentinian friends who might be on this call, these Los Carranchos. And the Carrancho is a crested caracara, but in Argentina, it's a euphemism for lawyers. So scientists were key actors through all of this. And we gathered, hopefully, unbiased information, such as, do owls need old growth forests? We answered critical questions that the public wanted to know, or the agencies wanted to know. Are owls declining? Or what effects do barred owls and extreme fire have on spotted owls? We have recommended and assessed management and conservation actions. And through all of this, most scientists have tried to be unbiased. But in general, scientists should also be willing to counter false information and misinterpretations of scientific information. This is something that scientists are often criticized about, that if somebody misuses some science, say draws an incorrect inference from what the data show, scientists, I think, are free to say, no, that's an incorrect interpretation. But some people don't want scientists to do that. They just want them to do science and shut up. Well, that's just not right, because I think we need to be able to explain to the public and to others what things mean. Okay, David had a slide of the northern spotted owl and other subspecies, and I'll explain a little bit more about a different slide showing the same thing. And that is, the northern spotted owl is a contiguous population, but then the California spotted owl, which she mentioned and I'll talk about a little bit below, that this is not only a large contiguous population in the Sierra Nevada of Eastern California, but also is distributed as a meta-analysis. Meta-analysis are nothing more than individual populations that are separated in space, but yet they interact with one another through dispersal. And if you look at the range of the California spotted owl, or the Mexican spotted owl, it's also a metapopulation. And this particular graphic here is probably incorrect, even though I made it, but we don't really know that much about the distribution of Mexican spotted owls in Mexico. So it's probably a metapopulation as well. So, as I mentioned earlier, the California spotted owl was not listed. And the reason why there was much resistance to a legal top-down solution of listing California spotted owl. So the Forest Service did something novel. And they created a technical team, of which I was a part, called CASPO, the California Spotted Owl Technical Assessment Team. And its purpose was to develop a plan that would, in the short term, prevent the extinction of the spotted owl, but primarily to avoid listing of the California spotted owl under the Endangered Species Act. Because once a species is listed as endangered, it really restricts what an agency can do in terms of their management. They have to go through consultation with the Fish and Wildlife Service. So the Forest Service really wanted to avoid this. However, once we developed that plan, the Forest Service immediately tried to change it. And many people felt that this was not in good faith. And so there were lawsuits and attempts to have this California spotted owl listed as an endangered species. And another example of this was the first northern spotted owl plan, which I was also on the recovery team, and we developed the plan. It was rejected, and others have been subsequently modified. These are all resistance to legal solutions. So here we have these top-down solutions being imposed, and now there's resistance to those in various ways. So now I'm going to talk a little bit about California spotted owl studies, which David didn't go into. And we do the same thing with California spotted owls as David talked about with northern spotted owls. The populations of owls or individuals within populations are banded and color marked. And as you can see here, we have these little color marks in there, and then the other leg has a band. And for those, and we have improved our capture techniques through time, such that now that the capturing is very innocuous and so much so that you can almost catch an owl immediately after capturing it again. And I won't say how to do this because some people use this in nefarious ways. But one thing that we do as biologists, we look to see how owls behave. And one behavior we've noticed, and actually Eric Forsman, a good colleague of mine, wrote a paper on this, is called allopreening. And this is when owls muss with the feathers of their mate or a juvenile. And this has a pair reinforcement, and it also calms them down and solidifies pair bonds. And we can do that to an owl. So when it's agitated, sitting there, you can just rub it on the head and they just close their eyes and go to sleep because they, oh, this feels so good. And they just think they're being allopreened. And so we take advantage of their own behaviors to calm them down. So just to give you an example, the same sort of thing that David talked about with all these northern spotted owls, we've done with many studies in the California spotted owl, and show that here occupancy declined in this one big population, the longest term population that I started in 1986 in the El Dorado National Forest of the Central Sierra Nevada. And then again, one of these novel advances in science, something we call realized population change, where each of these points is the proportion of the original population left. So you can see that it is declining over time. And Alan Franklin, one of my students and a good colleague of mine now, he developed this particular technique. But through time, technology has advanced. We didn't have cell phones or laptop computers when I started working on spotted owls, and we had clunky, bigger radio transmitters that were VHS radio transmitters. And now we have GPS technology. You can see how small these things are. This is an American dime, which is very small. And these things with the harness and everything only weigh 10 to 12 grams. And Dr. Zach Perry, one of my former students and now a professor at the University of Wisconsin, took over my studies in the California spotted owl and has taken them to much newer and greater heights, and using this GPS technology as well as many other techniques that they're developing. And one of his students, Sienna Zula, did a study which we've always wondered how an owl actually forages at night. So when we used originally VHF technology, we'd listen to them and we'd try to get a signal with our antenna. And then every once in a while, the owls would disappear. And we'd say, where are they? And we'd spend half the night looking for these things. And then we'd find them again the next night. We couldn't figure out what this was. So Sienna put these little transmitters on them, and she got a signal, a precise location or an accurate location every minute through the night. And this graphic will show you what an owl actually does during the course of a night. So this is about 16 square kilometers, this home range. And this little green spot is the nest site, and this is the owl. So what you're going to see, each one of these dots is an owl moving through time, whereas the 5 minutes location. And you can see it moves around quite a bit, but try if you can, and you got to be quick about this. Every once in a while, that white dot just shoots straight back to the green spot and then goes back out again. And when it does that, it's going back to the nest with a prey item. So here it is, and the timestamp is up here. Foraging out through time. Okay, now it's roosting during the daytime. You can watch up here the time going by. So this is the first night, went all around here. Second night. You get there twice, it went back to the nest. Didn't get it, did you? Well, now it's roosting. See if you can get it again. There it goes, right back in the nest. There it goes, went again. There it goes, 3 times. Okay, now it's roosting again. Back to the nest there. Back to the nest, back to the nest. Back to the nest. Okay, so it's amazing how thoroughly they're covering that their territory. There it goes. The last, I think this is the last night. That one went, I think, went 4 times. Okay, so because we have it every single minute, it turns out that when they start localizing a prey, they start staying in this little area, and they just get on some spot and they go like that. You know they're focusing in on something, and then they catch it, and then they zoom back to the nest. And we know that this is a foraging bout. Oh, excuse me. Let me go to that. We know that they're going back to the nest because we have cameras at their nest for the radio marked males. And what you're going to see here, this is the male that's arrived at the nest from one of these little bouts, and the female is in a nest right here. And Sienna had to identify this little prey item here. You can see his little eye right there. And to try to determine what the composition or what the species was, that to figure out the composition of prey deliveries. Always looking around for great horned owls or anything else that might. Calling to her. Now he gives her the prey. I don't know if you caught that bat that flew in there. Okay, so now the female goes back in the nest. Okay, so with that study was able to really focus in on how they're using their habitat, where they're finding it, how much do they use old growth versus non-old growth forest, and the like. Okay, so in getting to the Southern California metapopulation that I pointed out earlier, we have the same sort of studies as we did in the other places. This is one of my long-term study areas in the San Bernardino Mountains. This is the Los Angeles Basin to the left here, San Gabriel Mountains, and the San Jacinto Mountains. And again, the same trend, even in this meta population, shows occupancy declining over time, whereas reproduction just varies amongst the surviving individuals. Even though the population is declining, the birds are reproducing as a function of their habitat and also the weather. Okay, so this this resistance was again met with attempts to not to change CASPO, and as a result, people began to, as I mentioned, try to get this owl listed, and so to try to forestall that, they tried again to have bottom-up solutions, but bottom-up at a very large scale. And I'm to recall, these are solutions generated by groups that cooperate, but they don't have to be individuals or localized groups. They can be big groups of people that are trying to do this. And this is just these cooperative groups can be many structures: education, mediation, dialogue, groups working together individually to try to come to solutions. But in these efforts, trust and ideology were major impediments to bottom-up solutions. And I mentioned before, both the northern and the Mexican spotted owl were listed. In two previous listing attempts were rejected by the California spotted owl in resistance to that. In response to the resistance the agencies were showing to implement CASPO. But the California spotted owl should have been listed based on the criteria used to use the northern and the Mexican spotted owl. So why is it being proposed for listing now? Well, as I just showed, there's lots of evidence that these population declines are continuing. There's been new evidence of negative effects of megafires that wipe out entire populations. There's an instability in this metapopulation structure in Southern California. Some of these populations are gone or nearly so. And climate change has a big negative effect on their habitat through tree mortality and increasing fire risk. And of course, the thing that many people are interested in the negative effects of barred owls. So just to give you a couple of examples of these large bottom-up efforts were the Quincy Library Group, which is a community-based plan that required legislation for the U.S. Forest Service to cooperate, force them to cooperate with the community to develop a plan. And something called the Sierra Nevada Adaptive Management Project, which is all agencies in California and relevant federal agencies and communities throughout the Sierra Nevada try to work out plans to forestall listing and to create workable solutions. So to summarize this listing, CASPO preempted listing, and when there was resistance, there was two previous petitions that failed owing to the politics. Now these QLG and SNAP efforts failed for various reasons having to do with trust and ideology. Right now, there are too many additional threats to ignore it any longer. And I want to now switch gears and talk about these emerging threats. We got about 20 minutes left, so I'm going to move through here quickly. So there are three emerging threats here: climate change, fire, and barred owl. So climate change affects spotted owls in two ways. One, because spotted owls are north temperate adapted birds, that they have heavy plumage They get hit. They have a narrow thermal neutral zone. They get heat stress very quickly. So as temperatures rise, then they will naturally become more heat stressed. And there are indirect effects of climate change. There'll be increasing droughts, more severe droughts, which will induce tree mortality. And the tree mortality leads to a couple of things. One is that just an overall loss of habitat, and it creates a situation for severe fires. As far as fire is emerging threat, owls evolved and fire adapted for us. And so they're generally unaffected by low or moderate severity fires. But we now know, and I'm going to show you this in a second, that severe fires have a huge negative effect on spotted owls. And we've had an invasion of the barred owls. And we've seen that where they come in contact with spotted owls, they displace them. And so we think that they're going to cause the extirpation of not only spotted owls, but possibly other owls, and have impacts on many other species. So here's an example of the effect of drought. And when trees get stressed, they get attacked by insects. And you have these large tree die-offs. And this is in the Sierra Nevada, where millions of trees have died. And these become a tinderbox for fires. And one of the interesting things that happened when we first started working on these fires is there were two big fires, one in 2013 and one in 2014, the Rim Fire and the King Fire. And there were two studies following each one on owls. One showed that there wasn't no effect on occupancy, and the other was that there was a significant effect on occupancy. And other high severity fires have shown negative effect. Subsequent to these have shown a negative effect on fire. So the King Fire was a major fire. And in one night, this is our El Dorado study area that I showed you earlier, in which we'd had many years of data prior to the fire, and spotted owls all through this red color is where there was high severity fire. This green stuff where it was mixed severity, both low and high and moderate severity. And it burned through this in one night. And it was like, 40,000 acres that burned in a single night. So it was a huge catastrophic fire. And this gives you an example of what one of those sites would look like. These black dots are spotted owl sites before the fire. And that's what they kind of look like. This is what they look like afterwards. So nothing left on this landscape. And as I said, we had plenty of data beforehand. This fire was in a 95 percentile in size for these major fires, and we had much previous data. And what we found after the fire was that we had almost a complete disappearance of these owls. And we were able to compare natural occupancy without fire and occupancy with fire. And you don't need to be a genius to see that there's a fire effect there. And of course, the occupancy throughout the study area declined primarily because of this fire. And here, unburned sites, there's no difference. If there was less than 50% burned at high severity, there's no difference. But if there was greater than 50% of a territory burned, they basically just, I think we had one territory where they were still occupied. And then we put radios on these birds right after the fire, of the birds surviving around the fire, and they just don't use it. So plenty to show you that there's a major effect. Well, the people that did this rim fire and found no effect they criticized us quite severely. In many, they recruited people to write articles saying that we were horrible scientists and corrupt and whatnot, and did many other things like this. And finally, published a paper criticizing Gavin Jones's fire paper that I gave you a reference to earlier. They said that salvage logging caused a negative effect on owls and not fire. But we actually explicitly model salvage logging in our before-after control impact analysis of this king fire. They said we made mistakes identifying the birds, meaning either we're corrupt or incompetent, but we had all the owls color marked. And our home range estimates were biased because owls are what we call central place foragers. And that means that any species that has a nest and is tied to it, their home range size is naturally constrained by being tied to that one nest or the central place. But we explicitly model that. So they just chose to ignore our research. So we rebutted that in this paper, Jones et al. And they were unable to counter that our rebuttal. So we assumed that because they couldn't rebut it, that they had to, and other people have since accepted our results as having veracity. So why was there this conflict among scientists? And I think it's not really about science. I think it's about logging. So one of the proposals to reduce fire risk is to log smaller trees. And that's contrary to an agenda, one conservation agenda to prevent logging on national forests. And that's what I think really is the issue here. But I think that's a wrong approach, in my opinion. I think we should evaluate proposals and the strategies that agencies come up with to evaluate to reduce fire, and then monitor the implications of those strategies or the actual implementation of those strategies. And I'm guessing here about why this is not about science and more about politics and agenda, because there's a lack of trust. I think that occurs because there's a lack of trust in agencies to implement strategies as they're agreed upon. And people, as a consequence, have hardened their beliefs to an ideological position. Now, there are other emerging threats that I'll talk about here, and one is marijuana growing. And that emerging threat is not so much the marijuana growing as the illegal use of anticoagulants by pot growers. And it's an environmental crisis in California. Virtually every barred owl that's been removed in a removal experiment that Dave Wiens referred to is contaminated with these secondary anticoagulant poisons. But it also gets other birds of prey, carnivores, and both primary and secondary targets. And it's not clear how this particular conflict will go, but it's clear that it's a serious problem, and we'll hear more about it. And there's been a lot of research demonstrating the problem here. Now, many people came to this talk, I'm sure, to hear about this barred owl emerging threat. And from Dave's talk, we know now that there's almost complete range invasion of the northern spotted owl, and they're very abundant in this northern spotted owl. And they're displacing northern spotted owls everywhere. And they're also invading the range of the California spotted owl. And he pointed out there's been studies, or his studies, of northern spotted owl removal, but there have been one other study of northern spotted owls removal by Lowell Diller and his colleagues, but also California spotted owl with Zach Perry and his students. Now, the direction of this particular barred owl issue is not clear, but the biology is absolutely clear. And some of the actors and issues that we'll be facing in the future is the one over animal welfare. And we have biologists disagreeing about the appropriate approach for various reasons. There are conservationist disagreements about approaches. And then there's just agency inertia and fear. It took a long time for the agency to begin the studies that Dave affected, even though we recommended them many years before they occurred. So the invasion biology is clear, and I think we need to invoke the precautionary principle, and it's to do something to prevent such a high density of barred owls, and if possible, completely eliminate them from certain parts of their range, like the California spotted owl. So it's not entirely clear what these conservation actions, but there are certainly avenues to approach. So what to do about this situation? Well, the many alternatives have been articulated, not only in the literature, but also in the EIS that the Fish and Wildlife Service has published. How dire is the situation? I think the northern spotted owl will go extinct in most places, if not everywhere, if we don't do something. And how do we know this is true? Well, the experiments that Dave showed you, and he didn't express this explicitly, but experiments are the gold standard of science. Experiments are cause and effect. They are not trial and error learning. They're not correlational analysis. They are actual cause and effect. So we know that we can, in fact, or that the barred owl is, in fact, impacting the northern spotted owl, and we can change the trajectory of that effect by removal. But as was pointed out, barred owl impacts go far beyond spotted owl. And so what can we do here? Well, we got about 6 or 7 minutes, and I'm going to try to wrap up quickly here. Never, ever trust a headline in a newspaper or a magazine. Always read and evaluate an article for yourself and make your own judgment. I thought the AP article title that was published about hunters being allowed to kill spotted owls was a tremendous disservice to us as citizens, and a tremendous disservice to the U.S. Fish and Wildlife Service, because they explicitly said in their statements, this will not be hunters, this will be trained professionals who will do this under strict guidelines. Another thing we can learn from conflicts in general, never vilify people you know nothing about. This happened between loggers and environmentalists. I'm fortunate that I live in an area where I have loggers and neighbors, so I know them, and I know that at least the people I know are good people, and they have their own concerns, even though they differ from my concerns. Always seek reliable information. For science, that's peer-reviewed papers, but most citizens can't review peer-reviewed papers. And so what citizens should do, I think, is look for consistency amongst independent sources, not the echo chamber where you go to the same sources that say the same thing, but different sources. And then read the original interviews. Don't rely on somebody who said so-and-so said this. Go and see what so-and-so said. And if you do that little bit of work, and if you watch TV, you've got the time to do it. So That's my speech. So you need to be able to avail yourself of the broadest possible information. And then monitor the activities the agencies are conducting on management actions. You have ability to go out there and look to see what they do, or be involved with people who can do this. So yes, the spotted owl is a wicked problem, but when you get situations popping up like fire, the solution, or one of the solutions to lessening the impact of fire is to log small trees. You're right back to the beginning of the circle. We're logging the issue that created the problem to begin, or started the problem to begin with, because of its effect on all kinds of other things. Yet, in all conflicts, you have emerging threats, and you don't know what these will be, and they have the ability to upend solutions. So we have to realize that maybe the solution is not conflict resolution, but conflict management. So let's look at the roots of this problem. Okay, we talked about money, and this is, pure greed. People, that's the bad thing. But economic prosperity, economic well-being, all the rest of these are not bad things. They are good things. And this is something I call passion, in which you have socioeconomics, culture, politics, tradition. People are passionate about these things. And so long as they don't become fixed ideological, fixed action pattern responses, they're good things. The problem with ideology, it becomes entrenched. And no matter what you do, you can't change opinions. And underlying all of this is a lack of trust. So you cannot vilify people. And politicians all the time, as an example, vilify their opponents. Vilifying is one of the worst things that you can do, because it just creates ideological entrenchment. And I think that in terms of excuse me, go back here. This spotted owl conflict is sort of a reflection of larger issues. And I'll show you that this has been going on for a long time in terms of things like climate science, in terms of things like lead poisoning, smoking. And there's a wonderful book called Merchants in Doubt by Naomi Orestrix and Eric Conway, where they show that things that we've experienced in spotted owl conflict, fake news, alternative facts, fake science, vilifying science, so forth, have all been part of the effort to undermine the ability to control smoking, lead poisoning, and so forth, and climate change effects. National Geographic had an article, The War on Science, where they pointed out that there's a trend now to vilify science and science to create mistrust. If you don't trust scientists, then you don't believe them, okay? Even though, as far as I know, with a few exceptions, as we pointed out earlier, most scientists have tried to be unbiased in the spotted owl situation. And there has been undermining of laws and legal process by legislation, by the way rules are interpreted, executive orders that undermine laws. So all these things are things that just lead to more conflict. They don't actually resolve things. They just get people more angry, creating power imbalances through intimidation and threats, exploiting community threats like fire to advance other goals. And people in the Sierra Nevada and throughout California and the West Coast are very afraid of fire, and rightly so. And other people have used that to their advantage to move forward agendas. And then even the basic epistemological process. Epistemology is the study of the way we learn and think. And talk show, radio, television hosts, the bully pulpit, telling their audience, relax, don't bother thinking, we'll think for you. All of these things undermine the basic thought process that all of us should be going through to make good reasoned decisions. And, creating false equivalencies, your truth and my truth. Now, there's only truth, okay? And there may be things we like or don't like, but as far as science is concerned, there's only one truth, except, of course, when it becomes shown through better research that needs to be modified. So bad headlines like the AP can be either clickbait or they can be actual misdirection, political, as like the recent AP headline, or portraying information out of context. An owl found in a suburban backyard does not prove they don't need old growth forest. It means an owl got lost and made a mistake and wound up in the wrong place and likely is going to die. So this is something that single observations don't prove anything. And then repeatedly saying something is true when it is actually not true, like no fire harms owls, which is what projected on us by other people, saying that I said that. So when you say no fire harms owls, that's just a white lie, okay, which is basically a lie. But when you falsely attribute it to somebody else, like I just said, Rocky and colleagues said all fires are bad for owls, that's what we call a black lie when I was in the Army. And that's a lie attributed to an innocent person. All right. So I think, therefore, that owl conflict reflects broader societal values. And I'm going to end there because I'm out of time. And ranting and raving here. I was trying to move fast.
You covered a lot, Rocky. Do you want to stop sharing and then we can hop in and Joe and I will start forwarding some questions your way?
Okay, stop sharing. There we go. Okay.
You are muted.
I was indeed pressing my space bar, but it wasn't paying attention. So if people have questions in Zoom, please put those in the Q&A. And if you're in YouTube chat, you can type those into chat and those will get funneled over to me also. So I will let Joe start with a Zoom one.
What are the attributes of barred owls that make it possible for them to take over territories, and how do they outcompete the spotted owls?
Good question. And one of the papers that we published in 2007 in Invasion Biology discusses this at length. But basically, the barred owl is larger. And in a broader sense, in that paper, we looked at the coexistence of owls within the same genus. And it turns out whenever owls are close in size, but one's bigger than the other, then they won't coexist. And in the case of the barred owl, they're just simply bigger. They're far more aggressive and will attack spotted owls and actually kill them. In one instance, we think they killed them. We didn't actually see the kill, but there were barred owl talon marks in the dead owl in a barred owl sitting over spotted owl. And the barred owl has a generalist diet, so that it eats everything that the spotted owl does, which is has a more specialist diet, and everything else. So it is directly competing for food and also having sufficiently broader food preferences that it can have a much smaller territory and therefore have a higher density and crowd out spotted owls.
How do sparred owl calls differ from those of barred and spotted owls? And how would you call the barred owls?
Well, to call the barred owls, that's an easy one. You just use their own call. The sparred owl call is noticeably different. I can't reproduce it very well, but you can recognize that it's different, except this occurs mainly in the F1 and F2 hybrids. And when they're higher hybrid, it's difficult to tell. I once chased a spotted owl down in the Pitt River Canyon. It sounded like a spotted owl, looked spotted owl, but acted like a barred owl. It was very skittish, moved around, and I we finally caught it after much trouble, which usually isn't the case with spotted owls. They're usually relatively easy to catch. And when we did the genetics on them, my colleague George Barraclough from the American Museum of Natural History, he called me up and he says, "Rocky," he says, "did you make a mistake here and catch a barred owl?" I says, "No, it was a spotted owl. Trust me on this." And I knew there was something fishy about this owl, so I sat down after we caught it, wrote extensive field notes on what it looked like, and noted the oddities, a few oddities of its behavior and its plumage. And sure enough, it's probably was an F3 or higher hybrid. So the barred owl is easily called with its own call, but the spotted owl will actually respond to both barred owl and spotted owl calls.
Interesting. Do you want to, we were talking yesterday about the likelihood of killing the wrong species if people were playing calls. Do you want to talk about the experimental removal and how accurate that was for just getting barred owls and not spotted owls?
Yeah, so I mean, the Fish and Wildlife Service, and this is why the AP article infuriated me so much, that title, was because they were very explicit, and they even emphasized in their summary with italics that no hunters were going to be allowed to do this. It was going to be trained professionals who have been follow a protocol, and everyone is taught what a barred owl looks like, what they sound like, and so you have to both hear them and see them at close range. And thus far, with the exception of a spotted owl being mistaken for a barred owl, there haven't been any mistakes. It's pretty, but you have several things going on here. Now, when you use a barred owl call, spotted owls rarely respond to it, or if they do, they don't come into it, because we've done experiments that demonstrate that calling barred owls suppress the calling of spotted owls. So they know that when they're around barred owls, they're going to get attacked by them at this stage. So that it's unlikely from that aspect. It's possible that they could come in, but it's unlikely. Barred owls are their calls are very distinct relative to a spotted owl. Their plumage is very distinct, and you're looking at them with both a flashlight. I mean, a large illuminating flashlight, so you can see their plumage characteristics are quite different than spotted owls. And it's very difficult for a trained person to mistake a barred owl from a spotted owl. And in all of these removal experiments so far, that's just not happened for practical purposes. So I have 100% confidence that the Fish and Wildlife Service will get this right in terms of training and competent people.
We have an anonymous question saying, we've learned that one of the disadvantages to the spotted owl, northern spotted owl, is their broad home range versus that of the barred owl. Realizing that a prolonged timeline likely makes it impractical, are there logging and or restoration strategies to connect these home ranges that have any promise?
Well, that was the purpose of the Northwest Forest Plan and the original northern spotted owl plans, and which was to provide connectivity amongst groups of spotted owl territories, because you would have individual spotted owl territories that were their territories were disrupted partly between adjacent territories owing to past clear-cut logging. And by creating a reserve design where you allow these previous clear cuts to return to forest, you would increase that connectivity. And so it's a good question. And in fact, many people have have tried to do that. I mean, the Northwest Forest Plan is an example of people having been successful in doing that. The California spotted owl was a different strategy. Instead of having reserves, the idea was to have a contiguous forest cover of larger trees, and with logging occurring, taking the smaller trees, so that logging would occur over much of the landscape, but the very large trees would be protected, and there would be recruitment trees that would be allowed to grow up to large trees. So the two concepts were similar, to allow connectivity between adjacent pairs of owls and other species. And in both cases, that was a central feature of those plans. And it's a very good question, because people have asked, why can't you do this instead of removing barred owls? And the problem is, barred owls use all of these habitats, not only the old forest habitats, but they also use young forests and riparian forests and virtually everything in between.
There are at least 30 different species concepts right now. Approximately how many of these do you think consider barred owls and spotted owls as the same species?
I cannot think of any. The phylogenetic species concept, the biological species concept, which are the two major ones, both clearly indicate that they have distinct ancestral lineages and relationships genetically. And even though the biological species concept, in which the gold standard was interbreeding, we now know that needs, well, and people have modified it, because many species of birds that are congeneric or congeneric interbreed if their habitat is disrupted. So that suggests that a major isolating mechanism for interbreeding in birds is habitat selection. And the interesting thing with barred owls and spotted owls, we thought at one point that the Fish and Wildlife Service did, and many of us did as well, back in the early 90s, that a major issue would be hybridization and creating a hybrid swarm, because we knew there was hybridization occurring between barred owls and spotted owls. It turns out that that's not an issue, and that hybridization usually occurs when the barred owl is at very low densities, and so they cannot find mates. And it is the female barred owls, which are larger because they have reverse sexual dimorphism, mate primarily with male spotted owls. But once the density of barred owls reaches whatever density is critical to them, there's very few hybrids. I mean, they still occur, but very few. So there appears to be an issue that of hybridization as a result of failure to be able to find mates. Sort of an odd genetic allele effect of sorts. So barred owls have a hard time finding mates because they're advancing in their expansion, and so they find a similar species that has a similar call, and then mate. But after that, the hybridization rate is very low, if at all.
I'm going to combine
So they're good species, and I think everybody recognizes that they are good species.
I'm going to combine a couple of related questions. How do you propose killing the barred owls, and why is that more efficient than just moving them to other locations or other options? And if you relocate a barred owl, to where, and how not to disrupt the relocation ecosystem?
Yeah, well, see, that is the crux of the problem, right? So I don't think anybody involved in this, and of course I'm not directly involved with these northern spotted owl removal programs. I'm sort of a bystander here, but there is no place to move them. And people have asked. No state agency wants barred owls because where they occur in their range, or they're more or less fully occupying their existing habitat. Now, I heard this morning from Carla that in New Hampshire, barred owls appear to be declining. But even here, many people have argued against moving this genetic group back into the northeastern United States or the southeastern United States. So that's the one thing. There's no place we can move them. The second thing is that it's logistically very difficult, and that would mean you'd have to have far more people. You'd have to have holding facilities. You'd have to have transportation facilities, and on and on and on. So the logistics make it prohibitively costly to do this, and so really the only practical solution is removal, even as much as really nobody wants to do this. That's the only thing to do to prevent the extinction of the owl. And I encourage everybody to read the Fish and Wildlife Service's EIS. You actually still have 2 days to make comments, so you can go online, download the EIS, read it, and make comments by the 16th, if you so desire. But in that, they have many of these questions that you're asking now, and they've answered those. But they're good questions nonetheless, and it's important.
I think one of the other things we heard at the World Owl Conference this last fall by one of the researchers was they were finding some of the barred owls are picking up some diseases and or parasites out in their invasive range that are not native to the barred owl's native range. So if they were transported, they would be moving diseases into their native population that don't exist currently. So that was one of the other concerns. Another question, is there any data showing an increase in spotted owls anywhere else?
Very good question. Actually, there is. In the Sierra Nevada, no, I wouldn't say increasing, but stable. So virtually every population that we've looked at is declining. On the coastal populations, with the exception of one, and that is Yosemite National Park. So in the Sierra Nevada, which is the biggest mountain range in California, and it basically covers almost the eastern side of California, this particular population, we have 4 long-term demographic studies there. Or we did. There's one of them has ended now. But when we did metapopulation analyses of the long-term data, we were able to demonstrate that the Yosemite population, Yosemite and Kings Canyon, Sequoia National Park. Well, I should say Sequoia and King Canyon National Park, not Yosemite. They're close, but it's probably the same. But Kings Canyon, Sequoia National Parks, the populations were stable, and that was one of our long-term study areas. And the difference, it appears, is that Sequoia, Kings Canyon, and also Yosemite have been engaging in control burning to simulate historical fire regimes as best they can. And in doing so, they've created an environment that apparently is mimicking somewhat what original habitat was like. And of course, there's no logging occurring. So that these populations are in fact stable. So that's one thing. And in the Mexican spotted owl, there may be a population or two in the Southwest that is stable, perhaps the Sacramento Mountains or the Gila Wilderness in Southwest New Mexico, but many of the other national forest populations appear to be declining.
What's next in your research program on these owls beside monitoring their population changes?
Well, I'm just sort of hanging out, I'm just, whatever comes along, comes along. I work closely with Zach Peary and his grad students, and I do less as time goes on because I'm getting more interest in other things. But if there's something that Zach feels that he and his students think that I can help with, I will give them a hand. But I'm not actively searching out efforts. I will probably, though, return to some Mexican spotted owl work that we sort of curtailed back about a decade ago, and I want to pick that back up with Dr. Gavin Jones who works for the Forest Service in New Mexico, a brilliant young scientist who I really enjoy working with, and we've been talking about revisiting some of our earlier Mexican spotted owl work. So those are the kinds of things that I'm going to probably do with respect to spotted owls.
This kind of goes back to the other alternatives. Somebody was wondering how many barred owls have to be removed, and could they be relocated to educational centers and zoos?
See, a lot are going to have to be removed. I mean, there's thousands, and it's because the density is so high. I don't remember specifically what the Fish and Wildlife Service proposed, but it's going to be a lot of removal, and it's going to be continuous removal because they're going to be continually to move in. Now, what was the second part of that question?
Well, that probably sort of answers it. The second part was, could they be relocated to educational centers and zoos?
No, because there are going to be tens of thousands that will be removed over time. I mean, we can't even find the home for, a few dozen of them.
Going back to your hunting spot map recorder, at what stage were those GPS points recorded? Incubation or when the owls had chicks?
It was actually at the time they had young in the nest, but not outside it. So right at that time between hatching and the young still staying inside the nest. Some of them may have still been on incubating. So but before we had to get them before the young jumped out of the nest, because then you can't put a camera there and expect to see the prey delivery.
Here's one from YouTube. From the studies where the owls are after fires, is it known how far they move away from the fire site? Do they stay close to the edge, or are they going farther from the edges of the burn sites?
Yeah, well, here's one of the issue. I think I know what the person's saying is that if you had radios on them, what did they do when the fire came? And we don't know, because there were no radios on birds prior to these fires. So these fires, just in the case of the king fire, it turns out that was intentionally lit by an individual trying to cover up a theft. I think that was, and they just didn't get the fire out quick enough, and it spread rapidly and before it was contained. So if one could see a fire coming from some distance away and you have weeks to plan and order radios, then maybe you could do something like this. The only thing we do know that in some fires, especially the low and moderate severity fires, the owls must go somewhere, but they come back. And we've seen some that have dispersed elsewhere, but we also, in this king fire, we found the scorched bands of one adult. So, and it's only speculation what happened, but it turned out that this was a pair, and they had young, that they were dependent young that they were feeding. And these parents are very, very tied to those young. And I think that this fire moved, I'm speculating here, perhaps being anthropomorphic to a degree, but I think that pair was so intent on staying with those young birds, those owlets, and maybe trying to move them away from danger. And this fire moved so fast that it just caught them. And it was only pure luck that one of the technicians going in checking these sites after the fire actually stumbled on these charred leg bones and these bands, these burnt bands. So it can overtake and kill some of these birds. I think most of the time they just get out of there and try to find some other place, but they can't come back. Now, in the moderately burned areas, they'll come back. They'll come back to the sites. I mean, it'd be really interesting to see how they evade the fires and what they do. But so far as I know, I don't think anybody's actually had radios on them to discern that.
The King fire was exceptionally severe. The burn scar and salvage logging after effects can still be seen in satellite images clearly after 10 years. Is there a better quantitative way to piece apart fire effects versus a high or medium qualitative measurement? And have other fires other than King or Rim been analyzed?
So, so the first question is a technical one, and I think we actually didn't do it qualitatively. We did it quantitatively, in the sense that you have the proportion of the territory that's actually burned at high severity, or that's the proportion of the territory that's salvage log. Okay, so that's not qualitative per se. I mean, it's categorical for sure, but it's still a quantitative measure. We could actually model it simply using the number of acres in the territories, and how much was salvage log, how much was burned. We can do it that way as well. So that's not really an issue. I mean, I think we've got that covered. No, what the second part of the question was?
Have other fires been analyzed?
Yes, they have, and with just basically similar results to what we found. That if they're very high severity, they have a negative impact on the owls. So, this kerfuffle that we had with this other group of science, it sort of was put to rest, at least by most scientists, because more and more evidence that came forward from other research groups supported our original research. And actually, what needs to be done and hasn't been done is the rimfire data needs to be re-examined from sort of lag effects. So, okay, you had this result the first year forward, but were the owls still there 2 or 3 or 4 years later? And we've done that with the king fire, for example. We've looked at the continuing effects, and in fact, there are continuing effects. They haven't years later, as the questioner stated, they can still see these fire effects, and that's borne out by the fact that the owls haven't returned. And we've published on this, or Gavin Jones has led the research on this.
Could you talk about how a barred owl can be killed if it's a protected species?
How can they?
Mm-hmm.
The Fish and Wildlife Service creates a proposal and to get an exemption to the Migratory Bird Treaty Act to do this removal, and they explain this in their EIS.
And just, I'm going to throw on myself. Could you give examples of this being done in other species? Because I mean, it has been done in other species, correct?
Yes, it has. Probably the best example is the Kirtland's warbler and the brown-headed cowbird. And that situation, you had a very low population of Kirtland's warblers that's dependent on young jack pines to nest. And this usually was probably in the historic past a consequence of fire, but now you can replicate it by logging, clear cutting, and getting high densities of jackman to grow up in these young forests. But because of habitat changes and probably climate change, brown-headed cowbirds have expanded their range greatly, and they've invaded these areas, and so they're a nest parasite, and they parasitized Kirtland's warblers to such an extent that it was viewed that they were likely to cause the extinction of the Kirtland's warbler through nest parasitism. So the Fish and Wildlife Service embarked on a continuous long-term project of removing, trapping, and killing cowbirds, and so they have done this for a very long period of time. They've done this with cormorants to reduce the density of cormorants to reduce their impact on fisheries. They've done it with other species of birds and cowbirds and whatnot. And I think They've even done it in localized situations with peregrine falcons and great horned owls. And so anyway, this is not novel. We kill blackbirds and starlings by the hundreds of thousands to protect crops and the like. And so it's one of the things that has been a constant refrain in this conflict, or this brewing conflict here about control, is that let nature take its course. And yeah, that's an option. And that's what's called the no alternative or no action alternative in the EIS. And you can do that. That's certainly an option. But when you do that, the consequences is is probably the extinction of the owl and the extirpation of many other species, or at least they're near extirpation. As an example, I used to have, I see it right here in my own house. I always had screech owls, western screech owls, and pygmy owls around the house, and I don't have them anymore. I have 3 pairs of barred owls around the house, and I haven't heard a screech owl or pygmy owl in 10 years probably. And last fall, I walked up the driveway and saw a barred owl on the ground, and I kept walking. The barred owl went away, and it was killing a giant Pacific salamander, a dicamphidon. And these are huge salamanders that are like this, beautiful animals. And it was just eating it. And of course, I tried to save it because they're good at regenerating tissue, these salamanders, but it was too far gone. So that happens. This is a consequence for doing nothing. And then the extension, you have to extend this beyond barred owls and spotted owls and say, okay, if you're going to do nothing here, why are you going to do the cormorants? Why are you going to do the starlings? Why are you going to do anything? And it's a fact of life that we're in a human altered environment, and we don't want to constantly manipulate the natural environment, but in order to deal with invasive species and to try to keep some semblance of the natural ecology, sometimes these things are necessary from the viewpoint of many of us who are ecologists and who think this is a worthwhile thing to do.
Is some kind of reproduction control, like a hormone to suppress ovulation, a possibility aside from all the work to capture and release?
Well, I'm not an expert in that field. I just know that that's been proposed for something as common and as easy to administer to as deer, and they haven't been able to do it with deer. So, it's a valid question. It's a good question, but I just don't see how it can be done.
Somebody asks, or David Weens had said the best instrument for eliminating barred owls is shotguns. Is this the most humane approach?
Yes. Assuming the person is a competent shot, and all these people that are trained, they're not allowed to do collecting unless they are a competent shooter, and they use the proper size shot and the proper size load that will effectively penetrate this. And I hate to interject this because it's sort of not relevant, but when you get shot, and I've been shot twice, you don't feel, at least I didn't, the initial impact. And so I'm sure that if they would have been a lethal shot, then you don't feel anything. So I think it's humane, and I sort of projecting this based on my own experience with this. But that's another story.
And I'm gonna jump in with another one filtering over from YouTube talking about the manner in which they were going to be removed, because that feeds into the shooting, because that's the proposed manner, correct? Is
Correct.
shooting with a shotgun. And like they said, you can't really have a hunting season, and you had mentioned that it's not going to be it would, so what you talk about the training. I think if I recall looking through some of the documents, they talked like people are going through a course and take a test, or how can you?
Yeah, they have identification tests, hearing tests. There's a rigorous evaluation once they have the information that they need to actually affect eye removal. So I'm totally confident that they'll get this right, because they've proven they can do it already. So it's to me, it's not a matter of, oh, I should trust the Fish and Wildlife Service to get it right. They've already done it. They've already demonstrated they can do it. David Wiens demonstrated they can do it. So I'm totally confident that they can do this.
And then here's another one to tack on there. Do the young barred owls get killed? Or are you waiting till they have owlets, or I mean all ages?
Now I haven't read through this latest EIS in detail, but the current restrictions with the that I'm aware of, and what we were restricted to in the Sierra Nevada, is that you could not remove owls that had dependent young. And in my estimation, I think that this misses the point, because if you allow them to reproduce, then you're just continuing the problem. So I think that the from an efficacy point of reducing the density, it's better to allow them to shoot any owl. I mean, they wouldn't be shooting juvies, because the juveniles aren't coming into the calls, more or less. And the people who are doing the control are usually not specifically going into the nest sites, because that's just an increase in logistics and time and effort when they can simply call them. And these barred owls are so aggressive, you can get them to come from a kilometer away to where you are, which is not the case with spotted owls. Usually you have to go to them. I mean, sometimes they'll come up to you, but most of the time you have to go to them. And these barred owls are very aggressive, and so you can bring them from a long way away. So they're not necessarily at the nest site, that don't necessarily know. So I think that the restrictions they have now are excessive. That if the objective is to lower the density.
Here's possibly the big question that everybody has. What is the primary reason for the increase in expansion of barred owls? Do they have more food resources or decreasing abundance of enemies?
Well, the barred owl is a recent invader to the range of the northern spotted owl. And there's been several papers published about this. And of course, we don't know exactly what caused the expansion or why they expanded their range. And some people, of course, have said, well, it's just a natural range expansion and it's not an invasion. And in a sense, that's true. Every invasion that's contiguous with or fairly contiguous with a natural range is also an invasion. also a range expansion. But an invasion is different in that it is causing a negative effect of that range expansion. So that's the way I like to think about it. People who are aviation biologists might think about it more critically than I am. But be that as it may, we think that because of the changes in the Midwestern United States, which were prior to the settlement by Europeans, Native Americans were already here, obviously. This was the Great Plains of the United States. The Midwestern United States was the Great Plains, and it was a huge prairie, gigantic prairie, so large that barred owls couldn't find appropriate habitat to disperse through because they're a forest species. Now, once the Great Plains were settled, cities were established, fires were prevented that kept the prairie, the woody shrubs and forests out of the Great Plains. The forest expanded. People planted trees in cities, and so you had essentially little forests around all these small towns. And all along the riparian zones, they developed into forests. And what once was inhospitable habitat, grassland, now became suitable for barred owls. And we think that they just spread throughout this developing human-induced forest environment, whether they be woodlots or riparian forests or cities. And they came into the Pacific Northwest, southern Canada, Pacific Northwest, and then spread down where they had no competition and were much more adept at exploiting resources than this specialist spotted owl. And the other part of that was about natural range expansion, is that you have for millennia a species restricted to the what is now the eastern United States, that all of a sudden, for millennia, it just stayed there. All of a sudden, in the last 100 years, moves across the entire United States. I suppose that's possible that could happen, but the fact that it didn't happen for millennia leads me to believe that these hypotheses that it was the change in the environment in the Midwest that allowed the movement of the barred owl across. And of course, we've seen this with other species as well. It's not limited to barred owls. Warblers, flickers, orioles, all have shown this movement across the Great Plains.
Here's a question that plays back to something you alluded to at the beginning of your program about lead. Is lead-free shot used when they're doing the lethal removal?
Yes. Good question.
Where was my question here? Would you consider the proposed barred owl removal plans to be a bottom-up or a top-down approach?
It's going to be a top-down because it's going to be affected by a federal agency through some legal process.
After barred owls have been removed from previously occupied...
However, let me interject one thing. I'll go back to that one slide that Dave Weens had a couple of years ago, in which he had a graphic of all of the different groups that cooperated to agree to a removal experiment. That, to my thinking, was a bottom-up approach. So the Fish and Wildlife Service invited as many relevant parties, the animal welfare people, state and federal agencies, scientists, private landowners, tribes, and many actors that were relevant to this issue. And to that extent, and I was actually very impressed that they received 100% agreement to proceed with these removal experiments. That said a lot for the way in which the Fish and Wildlife Service conducted this, said a lot for the willingness of the individual parties to make concessions to actually understand whether or not the barred owl was causing these declines and so forth. So in that sense, the initial process was a bottom up. But now that the action is probably going to go beyond that, these West Coast parties, and we've seen this through comments made by other actors involved that are not happy about this, that the solution may be top down. The Fish and Wildlife Service using their authority to effect these removals. So I think it's maybe a hybrid in that sense. Okay, we'll go back. Sorry to digress there, but it's an important issue. And
after barred owls have been removed from previously occupied spotted owl habitat, are there experiments reintroducing captively bred or translocated spotted owls to reestablish the spotted owl population?
Not that I'm aware of, but there's an important corollary here, and that is in many of these, in several of these experiments, the one that Diller did, the one that Dave Weens did, and the ones that Zach Perry and his students did in the Sierra Nevada. In all of those, spotted owl territories that appeared to be vacant were recolonized by the original occupants or new spotted owls after the barred owls were removed. So by extension, reintroducing spotted owls in an area where they're no longer present would probably work. That's what I would infer from that reoccupation of these sites. So they're hanging around somewhere, they're just not breeding or interacting much. And then eventually they either move or they die. But if you remove the barred owls, if they're still there, they'll come back and occupy their old sites. So that's a good question.
Do we have time for one last one?
Yep, give them one more.
Okay. Do you think there's a stronger response to barred owl control than cowbird control because an owl's eyes and face are similar to a human's?
I do. Maybe not necessarily because of the eyes, but there is a well-known phenomenon that has been studied and reported on elsewhere that's called speciesism. So people view species in a hierarchy. If we were talking about wiping out mosquitoes, I don't think there's going to be a huge number of people that are going to be all freaked out about it, except some pointy-headed scientists and people who want to make sure that all life, and other people who want to see all forms of life persist. And I think that's valid. But when you move up into the hierarchy, certain animals are more important to them than others. So we're talking about barred owls now, and people are a lot more upset about that than they are about cowbirds. And they would be a lot more upset if we're talking about removing African lions than we are about something else than barred owls. And because they're a charismatic megafauna. So we are, because of our philosophical predilections, we do establish these hierarchical values for which species is more important to us and which ones were going to cause us to react more. And I mean, barred owls are really neat critters. And the people that are doing the control, the Fish and Wildlife Service people that are working on, nobody wants to see barred owls control. They just don't. But we also want to see the native species fauna continue to persist. And that's problematic. And if you don't do something, you're gonna have issues. And getting back to not doing something, people hemmed and hawed about doing something about barred owls for 10 years before they did experiments. And now, 10 years later than that, they're finally proposing to actually do control. What if we had actually reacted with a precautionary principle that I mentioned earlier in the talk and done it right away? It would have been much less expensive. There have been far fewer owls killed, and we'd have a much more intact ecosystem. And in fact, with the California spotted owl, which is just now invading, or the barred owls are just now invading the barred owl, we've removed most of them from the northern Sierra. So we're preventing them from entering, or we're trying to prevent them from entering the Sierra Nevada. And it's going to be easy to do because they're low density, and we find out where they are because we have acoustic monitors, or Zach and his students do have acoustic monitors all over the Sierra Nevada. And if these barred owls pop up, we go find them and remove them. So it can be done. And had we acted quickly, given what we knew and what appeared to be happening, and used the precautionary principle, then we wouldn't be in this pickle right now, in my opinion. And I think we're in the Cal Owl. I think we're going to keep them out of the Sierra Nevada. And thankfully, I was happy when I read or skimmed over the EIS that they're including the California spotted owl in their proposal.
Okay, I think that's a fairly good conclusion. And I sincerely appreciate all the time you put into this and are taking with everybody. We didn't get through all the questions. We got through quite a few of the questions, and I think there was really good questions in here that needed to be asked, and the public needed to hear answers to those because the media hasn't been doing a great job giving these kinds of answers. So thank you for helping the public to understand this. For those of you who are watching, this is going to be saved on our YouTube channel. You'll be able to find it either by going to YouTube and searching for International Owl Center, and we've got a playlist of our Virtual Owl Expert Speaker Series, or you can go to the International Owl Center website under programs and look for Virtual Owl Expert Speaker Series, and you'll find links to this one as well as David Ween's presentation that Rocky alluded to many times because it had lots of great information in it. And we appreciate all of you who are watching who want to get more information about this rather than, just go with shallow headlines or what you heard from somebody else. So very much appreciated that all of you are watching and learning more about this issue because it is complicated. It's not a simple issue. It doesn't have nice, warm, fuzzy answers. It's really complicated. And I think, Rocky, you did a magnificent job of covering all the angles of that this needs to be looked at to properly understand what's going on here. And thank you to everybody who made a donation to help support this program. We really appreciate that. That helps cover the Zoom fees and our staffing fees, because there's actually, between Joe and I here, we also have people over in the YouTube feed, and there's a whole bunch of other stuff that goes into it. It works out. We're happy to be able to do this. Just want to let you all know that the next webinar we're doing is going to be a much lighter topic. On January 28th, we're going to have Jim Wright and Scott Weston talking all about screech owls, specifically about, they've got a new book that came out that talks about, you know, if you want to have a screech owl in your yard, what kind of box do you do? How do you deal with squirrels? All kinds of other things. And a little bit about their biology also. So that should be kind of more of a how-to and a much lighter topic. So we hope to see some of you next week. And thank you again, Rocky, for taking the time with us. We really appreciate it.
Well, thank you for inviting me, and I hope everybody can take away the broader messages, especially if you're living in a different country. I mean, these issues are similar all over the world, and hopefully you can use some of it to your advantage in the future. Thank you, Carla.
Yeah, oh, and before we go, you have to show everybody your shirt.
Oh,
your sweater.
Yeah, this is a Chaco owl. My wife is a master knitter, and every year she makes me a wonderful sweater, usually owls, but not always, or something that some species I've worked on. So, you know, I'm probably one of the luckiest guys in the world to have such a wonderful wife, but who can, especially as talented as she is, to make these great sweaters. So.
Okay, there we go. So with that, we'll say goodbye and hope to see you again. Thank you all for watching and Rocky for doing the presentation. Have